All right, day 4. Some new proofs. So it says, given KOP and MAT, what can you conclude about P? Well, if I write MAT underneath here, I can say that I know that angle P is congruent to angle T. Name 3 pair of corresponding sides. Well, KO is congruent to MA. OP is congruent to AT. And KP is congruent to MT. And remember, I just look at this and say KO, MA, OP, AT, KP, MT. That's simple. If you line them up, it makes your life so much easier doing this. I promise you. All right, decide whether they're congruent. If so, write the statement and which rule. Well, remember, this is one of those special ones where this line, JK, is congruent to itself. So what do we have? We have a side, we have an angle, and a side. So yes, we have this by SAS. Now, XKJ. X, down highway 1, up highway 2. Which means we're going to start at Y, highway 1, highway 2. So that's YKJ. All right. Over here, we have 1 matching with 1, 2 matching with 2, and 3 matching with 3. And you might think this is easy, and it is, by SSS. But what screws people up is they go AFC, they go, oh, DFB. But no, you've got to be careful. If I'm going AFC, I'm going down highway 3, then 2, then 1. So, starting at D, I can't go down highway 3, can I? Which means I need to start over here at B, highway 3, highway 2, highway 1, and get triangle B, F, D. All right, over here, let's see what we got. We know we have a side congruent to a side. And we know if this is 60 and 70, okay, that's 130, which makes this 50. So this angle is congruent to this angle. And then we know that this side is equal to itself. Now we have SAS. And if we're doing PRT, no name highway, highway 2, highway 1. Now to go down 2 before 1, I have to start at S, no name highway, highway 2, highway 1. So that's SRT. Okay, just a little review. Okay, new stuff. 2 new rules, ASA and AAS. Obviously, ASA is going to be angle, side, angle, and AAS is going to be angle, angle, side. So, it's going to be the same objective. So, yesterday we learned about SSS and SAS. And really important, remember, no ASS, also known as SSA. Very important. Please write that down. All right. Included side. Just like yesterday, we had the included angle, which was the angle between 2 sides. The included side is the side between 2 angles. Pretty simple. So let's look at this. For X, angle X and angle P. Angle X. Let's try that again. Angle X and angle P. What is the side that is included? Well, really, that's just the side that connects the two letters. And it's literally just those two letters right there, XP. So for A and X, it's just going to be AX. It's the two letters making a side. Which two angles make AP? Well, that's pretty self-explanatory. Angle A, angle P. So, angle, side, angle. You basically have an included side between two congruent angles on both triangles. So again, if we do that little trick where we say ASA, what do we have over here? ASA, we can prove it. So example 1, does ASA work on these? All right, well, we have a 1, we have a 1. We have a 2, we have a 2. And then we have a side marked congruent here and here. So if we just go by and say we have an angle here, we have a side, we have an angle, side, angle, then yes, we can do it. So now we just got to follow along. Dog. So starting at D, going from angle 1 to angle 2 and up and back. So on this one, starting at angle 1, angle 2 and back, that's going to be TCA. Just follow the order. All right, right now it looks like we don't have enough information on B, but don't forget, that side is equal to itself. We're looking for ASA. Well, what do we have? We have an angle here. We have a side here and a side here. That's one of our no-nos. So we say no or NP for not provable. All right. This one's confusing because it looks like M and B line up. All right? But notice M is congruent to W. So your eyes can deceive you. Now, we have an angle there. Angle and angle there. They're both 90. So if we wanted to, we could do this, but we don't have to because 90 equals 90. Now let's see what we have. We have angle, side, angle. Oh, we're good to go. Side, angle, angle. Board is not cooperating here. So again, that is no. We don't have the included side on both of them. So that's again no or NP, not provable. Okay, angle, angle, side. If two angles and a non-included side of one triangle are congruent with two angles and a non-included side of the other, they're congruent. So here we have, well, it's going to be a big A. AAS. AAS. That's an okay rule. So let's practice it. Does AAS work here? Well, let's see. We have an angle here, a side there. Angle, 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 angle. So what do we have? We have side, angle, angle. Here we have angle, angle, side. So that would be no. Not provable. We need some other information. Let's go over to B. Well, let's see what we got. We got A congruent to H. We got W, AWS compared to HWS congruent. And then we have this, side equal to itself. So here we have AAS, that looks good. AAS, that looks good. Yes, it works. So, W, down highway 1 towards angle 2 and back. Down highway 1 towards angle 2 and back. So that's WSH. On to C. Okay, we have this side matches this side. That angle matches that angle. This side matches that side. Well, what do we have? We have SAS. SAS. Let's look at our instructions. Are they congruent by AAS? Now, I'm only going to answer no here. I'm not going to put NP because it is provable. It is provable by SAS. But the question was, can you prove it by AAS? And that answer is no. But we could prove it by SAS, and we're going to do that just for extra practice. So MAP, no name highway, highway 2, highway 1. No name highway, highway 2, highway 1. BWO. And we'll say by SAS. So it is provable, but with a different rule. Okay. Now we can use any rule we want. So let's see what's going on here. We have this side and this side. And we have an angle here and an angle here because they're vertical angles. Now, be careful. It looks like we don't have enough information, but look at these triangles. Right? So we're going to step back and say, wait a minute. I have two parallel lines right here. And I have a transversal. And what do we know about transversals? We know between parallel lines, alternate interior angles of the transversal are congruent. So, what do we have? We have AAS, AAS. Now, that's also a clue as to how it's going to lay out when we do our statement. Because HOU. So HOU and back. So no name highway, highway 1 and back. So we're going to start here at E and go no name highway, highway 1 and back. ESU. And we say by AAS. Another hint to the direction was AAS, so it's going to have to go AAS that way. Okay, number 2, what do we have? We have this side, and we have this side equal to itself. Now, let's look at the directions again. It says, are they congruent? So right now, we have a side and a side, side and a side. The problem is we don't know anything about EU or UL, and we don't know anything about EBU or LBU. We would need this angle and this angle congruent for SAS, or this side and that side for SSS. Okay, we don't have that, so it's no, or not provable. Don't have enough information. Oh, looky, looky, we have parallel lines again. So we know we have vertical angles here. We have alternate interior here. We're also going to have alternate interior here. So let's see what we have. We have an angle, a side, and an angle. Angle, side, angle. Okay. We also have, and this is going to be kind of confusing, we also have angle, angle, side. So this is one where we actually have two choices. We could prove it two different ways. Now let's look at tin, T-I-N. Okay, starting at 2, going to 3, then to 1, 2 to 3 to 1, 2 to 3 to 1. So KSN. But we can say by ASA, and we can also say by AAS. So there are choices there. And that's it.